What did I just finish saying? What do we do first? Substitute. So is this indeterminate? If I put 0 in, I get 0 plus 8, which is 8. Cube root of 8 is 2. 2 minus 2 is 0 over 0, indeterminate. Okay, so sub first and see if it's indeterminate. FYI, we used to do two extra strategies on this day. We cut one of them, so there's only one strategy, so the homework solutions and stuff like that will look a little bit different, but you don't have to know how to do the other one, so don't worry about it, okay? If it ever comes up in anything, it has to do with absolute value, so you can ask me if it comes up, but we're not doing it. Okay, so this is the last strategy. You got to recognize a strategy. It happens when you have a cube root or something like that. Square root is rationalized. Cube root is different. Actually, I should have asked you, because most people think, can you rationalize that? Can you use the conjugate? But it doesn't work. There is such thing as a conjugate for cube roots, but it's a lot more complicated. Okay, you know how like a difference of squares is just x plus 9, x minus 9? And that's what the conjugate is? If you got x plus 9, you multiply by x minus 9. Well, what's the formula for the difference of cubes? It's got 3 terms in that second part, doesn't it? So you would have to do something like that to do a conjugate for cubes. So we don't do it that way. Okay? So our strategy in this case is called substitution, or you don't have to memorize the names of them, but I'll use them sometimes, so it's good to know the names, or change of variable. That's the name of the strategy that we are using. Okay? So once you recognize that that's a strategy, once you've subbed in and see that it's indeterminate, and you've recognized the strategy that you're using and it's change a variable, there's 3 mini steps that you have to do, and you have to show all 3 for a mark. Okay? To change the variable, and then you sub back in, and then you solve relatively easily from there. You have to do these 3 steps. You have to do them correctly. Some people don't bother learning it. Some people don't. It doesn't click for them, and they just write a bunch of junk on the page, and then just nothing happens, right? And you just get 0 on that question or whatever. So like this is something that you're not going to figure out unless you practice a bunch of times and really get it. The change of variable part, this part that's 3 small steps, is the most important part. So you have to know them. First thing I'm going to just point out, this is not one of the steps, but remember we know that the cube root, what's another way of writing the cube root of x plus 8? To the 1 over 3, right. Okay, so often that's a better way of writing it when we're doing algebra with these things. First thing you do is you pick your variable. For some reason, we often use a or u. I don't know why. Use whatever you want, but make sure it's clear. Probably you don't want to use the letter o. Okay, and we do this. Let a represent this thing, x plus 8 to the 1/3. Notice I'm not including the minus 2. If you did that, you could make this work, but it would be a lot harder, and you'll probably do it wrong. So just the radical part. Okay? That's the first mini step of this 3-step process. That means a equals x plus 8 to the 1/3. So we have to use a let statement because we're introducing a new variable, but we're saying it represents that, which means they're equal. Step 1 is pick your variable, let statement. Step 2 is set up this equation and solve it for x. How do I solve this for x? First step. Nice. Cube both sides, gets rid of the 1/3. Raising both sides to the 3. Like if I did this, x plus 8 to the 1/3, all to the 3, you multiply the exponents. 1/3 times 3 is 1. So you just end up with x plus 8. Yes? Next step, I hope that's easy. Subtract 8 from both sides. I have isolated for x. Is that okay? Third step. As x approaches 0, you have to determine what a approaches. What does a approach as x approaches 0? Nasir, do you know? No? How did you get that? Exactly right, yeah. So you use this equation and solve for a. Sub x in, sub the value, not always 0. It's 0 because our limit is approaching 0, right? That's why I did 0. Is that what you were going to say? 2? Nice. Okay, so I sub this value in right here. I sub it in to this equation. Solve for a. 0 plus 8 is 8. Cube root of 8 is 2. As x approaches 0, a approaches 2. Once again, 3-step process, mini steps 1, 2, 3. I have to see all 3 of those steps. They have to be written out in full. They have to be done correctly, obviously. Okay? Yes?
So do you want to see your steps to find a as well?
You don't have to show this middle step. Is that what you're asking?
No, like when you go like a approaches 2.
You just have to show me these 2 things.
Not like that one.
You don't have to show the algebra. You can do it in your head by inspection or whatever. Generally, it's going to be easy to do. So this is the minimum you have to write. You can't write less than this. You can write more if you want, but what I write is always good enough, right? Okay. Okay? 3-step process, 3 mini steps, 1 mark on your test. Now, I substitute everything that I can. So this now becomes the limit, equals the limit as a approaches 0? No, 2. You have to actually do the substitution. Some people miss that. Okay? What can I substitute in place? And you should not have any x's left. The whole point is we're changing the variable. We're not going to have x anymore. What can I substitute in for the cube root of x plus 8? Zara? Huh? A. This becomes a, minus 2 over, what can I substitute for x? Check. A cubed minus 8, this thing right here. A cubed minus 8. Folks, this is a powerful mathematical strategy that we use in all kinds of other places the first time you're seeing it, but change the variable is kind of a big deal. It's really, really powerful. We just took something that would have been quite difficult to solve the way it was. We made it pretty easy. Because what are we going to do now? Megan, what do you think? Yeah, factor, right? Difference of cubes. We're factoring it, and the hole's going to pop right out. So let's just do that. There's my a minus 2. Remember, my rule is you got to write this out one more time. 1 over a squared plus 2a plus 4. Sub in. Four plus 4 plus 4, 1 over 12. Huh? What do you think? How do you like that? And you don't have to sub back in to find x. Like, that's the answer. That's the limit. Done. Pretty cool, right? Yep.
Could you use that for squares instead of the conjugate?
Yeah, I would think so. Now, It might be. On a test, no, because I want to see that you know how to use the conjugate. But yeah, it would work. I don't see why not. Okay. One more. This one's a bit different for a few reasons. Yes?
Could you factor like a squares?
Good thinking. Hold that thought. We're gonna change the variable first. Okay? So we tend to see cube roots or sixth roots for these questions. It could be other ones as well, but those are the ones we tend to see. So again, this is like the sixth root of x minus 1 over x minus 1, right? That's what this is like, but it's written with the exponential form. Those are the ones we tend to see. Thirds and sixths. So when you see that, you know it's change of variable strategy. So we're going to do the same thing. I'm going to use u this time just because those are, for whatever reason, the ones we tend to use. Let u represent, what? X to the 1/6. Stop. Just the radical part, not the minus 1. You include the minus 1, you're going to confuse yourself. So this one's also a little bit different from the other one for that reason. It's just an x as the radicand, not like an x plus 8 or something like that. Okay, next part is u equals x to the 1/6. Raise both sides to the exponent 6. And u to the 6 equals x. Last part, Ibrahim?
It would be x, as x approaches 1, u approaches 0.
You sure?
You have to be taking 6
Sixth root of?
0.
Sixth root of?
1.
Yeah, that's okay. So what is it?
I don't know.
You know the sixth root is 1. It's 1, right? Yeah, just like a root of 0 is 0, a root of 1 is 1. Good. Okay, as x approaches 1, u approaches 1. So in this case, that part didn't change. 1, 2, 3 parts to this. Like I would have that in my head. There's 3 parts. I need to get all 3. You know what I mean? Limit as u approaches 1, I can replace x to the 1/6 with u, and I can replace x with u to the 6. I didn't talk about the sub in, but we would have subbed in to make sure that this is indeterminate. It is, right? Everybody good? Remember, there's no more x's left. We've changed the variable. It's only u's. Only u's. Now what do we do? Do you know how to factor this? Can you factor? You do? Yeah, you do maybe, but some of us maybe don't. We've got a rule for a difference of cubes that we just used. We've got difference of squares, but Jack, you had an idea earlier.
Could you factor this u cubed minus 1 times u cubed plus 1?
This is a difference of squares, isn't it? And remember back in grade 10, you did these questions and it was harder. You did like higher degree polynomial questions. And we push your understanding in grade 10. But by the time you get here, hopefully you understand it by now. And you see that this is a difference of sixth. It's a difference of squares. It's also a difference of cubes. I could factor this as a difference of cubes. It would be u squared minus 1 times u to the 4th plus u squared plus 1. But I'm not going to do that. You could do that if you want, but that's the harder way of doing it, I think. Okay? The easier way so this is going to be u cubed minus 1 and u cubed plus 1. Now what do I do? Zara?
Because when you're going to take u minus 1, you can just leave the stuff the rest of it. And then do the cube stuff for the first one.
Nice. Exactly what I was thinking. We don't have to touch this part, do we? We don't need to do anything to that because I know the factor I need to divide out. I know my whole is hiding in there. So I leave that part alone. I leave the u cubed plus 1 alone, and I factor the other part. So you still have to factor a difference of cubes, but it's a bit of an easier one. Don't forget that you still have the u cubed plus 1 there. Oops. Okay, write that one more time, and then I can sub in. 1 over 1 squared plus 1 times 1 cubed plus 1, which is 1 over 3 times 2, 1 over 6. Questions?
Wait, at the top, when you wrote for the denominator, u6 minus 1, do you assume it's minus 1? At the top, it said, yeah.
That's right.
I know, but like at the side, you wrote u6 equals x3, just like, you know what I mean?
So this was, yeah, I don't know that I know what you mean, but this was an x. X equals u to the 6.
Oh, right.
So I can replace x with u to the 6. You know what I mean? Like, think of it as straightforward and simplistic as that is. If x equals this, I can replace this in for x. Right? That's as simple as it gets. Because this is harder. This is a trickier strategy than the other ones. You've had more practice with the other ones too. Like, very often a bunch of people get this one wrong. Okay, so this one's not easy. It looks easy. Don't forget, your teachers always make things look easy. That's their job. It's not easy. So practice it a few times. Make sure you get it. But that's one thing that you can do. When you get to, if you know how to do this, and then you're trying to substitute, you just say, well, what equals what? And just sub it straight in for that thing. Any other questions?